The announcement of the Tesla Model 2 emerges as a milestone that redefines expectations, uniting accessibility and high technology in a proposition that challenges the entire logic of the current automotive market, where electric vehicles are still perceived as premium products and distant from the masses. Now, with a projected price of $15,900 and a launch scheduled for November 2026, Tesla positions this model as the first major step towards democratizing global electrification, offering a ESS vehicle that not only aims to compete with popular combustion engine cars like the Corolla and Civic, but also to inspire an irreversible cultural shift around mobility, energy, and sustainability. The impact of the Model 2 begins long before it hits the streets, as its very existence alters the public debate on transportation, placing for the first time an advanced electric car within the financial reach of the global middle class, something no competitor has managed to achieve on a large scale. This strategy combines industrial ambition with social vision, attempting to transform the electric vehicle from a status symbol into a practical instrument of everyday evolution, capable of replacing millions of combustion engine cars without demanding sacrifices in comfort, technology, or range. By planning the launch during the 2026 annual meeting, Elon Musk positions the Model 2 at the center of a historic moment, creating a scenario where media impact and technological drive intertwine to generate a global narrative of change, making it clear that this model is not just another car, but a technological manifesto that directly questions traditional business models and the automotive industry's reliance on high profit margins based on fossil fuels. By announcing a vehicle designed for the average consumer, Tesla breaks with the perception that electric cars are futuristic luxuries limited to high-income consumers, inaugurating a phase where cutting-edge technology is treated as a basic necessity, and this movement forces traditional automakers to revise their strategies, mainly because Chinese competition already offers affordable electric models, making this global battle a decisive point for the future of the industry. The Model 2 represents not just a product, but the beginning of a new mass production ecosystem driven by extreme efficiency, in which adjustments to assembly lines, new partnerships with suppliers, and perhaps even factories dedicated solely to this model will be fundamental to achieving unprecedented production costs, challenging rivals who still grapple with slow, fragmented industrial structures, unable to compete at Tesla's accelerated pace. Tesla's competitive advantage lies not only in its embedded technology, but also in the industrial scale it dominates, allowing the Model 2 to be manufactured in gigantic quantities, reducing unit prices, and creating a virtuous cycle where each new sale generates more data, more efficiency, more energy, and more innovation capacity, making each Model 2 unit not just a car, but a cog in a constantly expanding living system. The centerpiece of this project is the aluminum-ion battery, a potential replacement for lithium batteries, whose estimated energy density could reach $500 per kilo, double what is seen today. This transition represents a monumental technological leap, capable of reducing costs, increasing range, and raising safety to levels never before seen in automotive batteries, all with a direct impact on the final price of the Model 2, which becomes more competitive without compromising performance. This battery has a strong narrative impact. While lithium dominated the market for decades, now emerges an abundant, recyclable, and highly stable material that can reduce fire risks to almost zero, thanks to its non-volatile and high-temperature resistant electrolyte, allowing the Model 2 to offer a safer, more efficient, and reliable user experience, especially for families hesitant to adopt electric vehicles for fear of thermal instability. The durability component also elevates the Model 2 to revolutionary status, as the expectation of up to 10,000 recharge cycles represents more than 20 years of intensive use, transforming the car into a long-term platform that drastically reduces maintenance costs throughout its lifespan, eliminating common degradations and bringing an unprecedented economic logic, where the car becomes virtually immune to the traditional wear and tear that consumes owners of combustion engine vehicles. The expected charging time of between 10 and 15 minutes to reach 80% creates a new usage scenario, reducing psychological barriers such as so-called range anxiety and bringing the process of charging an electric car closer to the traditional act of refueling with gasoline. And under ideal conditions, charging could even approach 3 minutes, a number that, if confirmed, will redesign the entire urban infrastructure and redefine what electric mobility means. Superior thermal efficiency makes the aluminum battery a robust solution for hot regions, where lithium batteries suffer performance loss, and this expands the Model 2's penetration capacity in emerging markets such as Latin America, Africa, Southeast Asia, and the Middle East, regions that have historically faced difficulties with technology sensitive to extreme climate variations, and that can now receive a vehicle fully adapted to the local reality. Despite their advantages, aluminum batteries face limitations in very cold climates, where there can be a 10% to 20% reduction in range and charging speed. This requires transparent communication from Tesla and strategies that adapt vehicle use to ensure adequate performance in regions such as Canada, Norway, and parts of the United States, where low temperatures are part of the seasonal routine and directly affect any energy technology. Another crucial challenge lies in the ultra-fast charging infrastructure needed to harness the full potential of this battery, as the supercharger network will require substantial upgrades. This process will be gradual and will require massive investments, but it represents the logical step towards enabling a future where millions of vehicles recharge in minutes, creating more efficient urban flows and reducing congestion at charging stations. The transition from prototype to mass production is always the weakest point for any emerging technology, and the aluminum battery will be no different, as Tesla will need to ensure consistency, reliability, and competitive costs across millions of units. This requires advanced engineering and rigorous processes that are time-consuming, capital-intensive, and involve realistic testing, essential to avoid unexpected failures during the first few years of use. In designing the Model 2 to cost less than $20,000, Tesla needs to make pragmatic design decisions to eliminate superfluous components, replacing continuous LED headlights with more traditional options, removing the panoramic sunroof in favor of a metal roof, and opting for single glazing instead of double glazing, creating a package that preserves the brand identity without wasting resources on elements that don't directly impact performance or safety. This simplification process is carefully studied, as each technical choice seeks a balance between cost-effectiveness, comfort, and functionality, allowing the Model 2 to maintain the Tesla essence in driving, handling, connectivity, and software experience, even while reducing luxuries such as premium sound systems or vegan leather upholstery, resulting in a minimalist, efficient, and highly competitive car. Compared to popular cars like the Toyota Corolla and Honda Civic, the Model 2 offers clear structural advantages: zero emissions, extremely low maintenance, advanced onboard technology, and lower operating costs, creating a scenario where combustion engine vehicles are beginning to seem outdated not only for environmental reasons, but also for personal savings, energy efficiency, and functional longevity. The starting price of $15,900 becomes a game changer in the global market, as it eliminates the financial argument that hinders the mass adoption of electric vehicles, transforming the Model 2 into a superior alternative in almost every criterion that matters to the average consumer: total cost of ownership, robustness, range, safety, connectivity, and predictability of maintenance, items that traditionally favored combustion engine cars. The possibility of the battery lasting 20 years places the Model 2 in a different economic category, making it more of a long-term investment than a disposable product, breaking with the paradigm that cars need to age quickly and require periodic replacements of critical components. On the contrary, the Model 2 proposes a sustainable logic that reduces family costs and extends the vehicle's lifespan without additional effort. Zero emissions make the Model 2 part of a broader energy transition program, aligned with global goals for CO2 reduction and the adoption of clean energy, creating a significant environmental impact when multiplied by millions of units sold. This transforms the car into an active agent of sustainable policies, encouraging governments to accelerate changes in infrastructure, incentives, and legislation geared towards electrification. The comparison with combustion engine cars is becoming increasingly unfavorable to traditional models, as internal combustion engines depend on complex systems, inevitable mechanical wear and tear, and constant maintenance, while the Model 2 radically simplifies this relationship, offering an electric platform that is almost immune to common problems, capable of running hundreds of thousands of kilometers without major interventions, profoundly altering the relationship between owner and vehicle. The launch, scheduled for November 2026, is generating enormous anticipation, as it coincides with events where Tesla historically announces products that change the course of the industry. The presentation of the Model 2 promises to be one of those moments, capable of capturing global attention and generating a wave of analysis, debate, and speculation that fuels both investors and ordinary consumers, expanding the project's visibility on a global scale. The pre-launch period will be dominated by rigorous testing of the aluminum battery, final adjustments to the simplified design, and calibration of the production lines, creating an environment of accelerated improvement, where each prototype provides crucial data to ensure that the final product reflects Tesla's commitment to efficiency, safety, and continuous innovation, characterizing an evolutionary process that precedes any major company launch. After its launch, real-world performance in daily use will be the ultimate test of the promises made, as only real-world conditions can validate range, durability, fast charging, thermal efficiency, and operating costs. This period will be closely monitored by analysts, the press, and consumers, all eager to see if the Model 2 truly delivers on its promises and positions itself as the most important vehicle in Tesla's history. Commercial success depends not only on technology, but also on Tesla's ability to balance price, quality, and industrial scale, creating an ecosystem where the car is just one part of a larger whole that involves charging, software, maintenance, support, and continuous updates, generating an integrated flow that redefines what it means to own a modern and affordable electric vehicle. Tesla's goals extend beyond the car itself, as the adoption of the aluminum battery also represents an effort to consolidate broader new production chains, reducing dependence on countries dominant in the lithium market and creating industrial opportunities in regions where aluminum is abundant, expanding the company's technological and strategic autonomy. The price stability of aluminum, much lower than that of lithium, creates economic security for long-term production, reducing financial risks and ensuring that the Model 2 can maintain its affordable price even in the face of global fluctuations. This benefits consumers, governments, and distributors, establishing a more solid foundation for the future of electric mobility. The easy and inexpensive recycling of aluminum reinforces the environmental appeal of the Model 2, transforming each battery into a closed-loop energy and reuse cycle, reducing the need for aggressive mining and bringing Tesla closer to a circular production model, capable of operating for decades without depleting natural resources at worrying rates. The abundance of aluminum, between 800 and 2,000 times greater than that of lithium, ensures that large-scale production will not face bottlenecks like those seen in traditional batteries, eliminating the risk of shortages and expanding Tesla's capacity to manufacture tens of millions of vehicles over a few years, something essential for the global electrification plan. Ultra-fast charging gives the Model 2 a competitive advantage over any other electric vehicle on the market, allowing for fluid, practical, and integrated mobility in daily life, with minimal waiting times and much more dynamic urban operations, elevating the experience of driving an electric car to a standard close to the instant refueling of fossil fuels. The thermal safety of the stable electrolyte puts an end to long-standing fears of fires and explosions, making the Model 2 one of the safest electric vehicles ever designed. This reinforces the confidence of consumers who still resist electrification for fear of instability, creating a more favorable environment for mass adoption. The high range, derived from the energy density of the aluminum batteries, allows the Model 2 to travel long distances with ease, bringing it closer to more expensive mid-size vehicles and eliminating limitations that usually affect compact cars, making it suitable for both urban use and extended trips. The combination of advanced software, OTA updates, and state-of-the-art sensors creates a technological layer that differentiates the Model 2 from its combustion engine competitors, offering a living, constantly evolving system that improves over time, transforming the vehicle into an intelligent device on wheels. Native integration with the Tesla ecosystem expands the functional reach of the Model 2, enabling optimized energy use, complete vehicle monitoring, intelligent navigation, and advanced safety features, consolidating a sophisticated digital suite that is typically only found in more expensive vehicles. Pressure is mounting on the global automotive industry as the Model 2 moves into production, since traditional automakers need to accelerate their electrification programs, overhaul supply chains, and rethink pricing, confronted with the prospect of a highly efficient, inexpensive, and technologically advanced competitor. The psychological effect on the market will be profound, as consumers who previously considered electric cars inaccessible will now see the Model 2 as the gateway to a new era of mobility, creating desire, curiosity, and a sense of technological inevitability, accelerating the gradual abandonment of combustion engines. The adoption of the Model 2 could redefine legislation, influence public policies, and inspire government incentives, as a cheap and efficient electric car strengthens decarbonization initiatives, bringing large-scale economic, environmental, and social impacts, especially in developing countries. The after-sales cycle also benefits, as the low maintenance requirements reduce family costs and create a more direct and simple relationship between the owner and the vehicle, eliminating frequent trips to workshops, oil changes, belts, filters, and other elements that define the experience of a combustion engine car. The simplified design of the Model 2 does not diminish its identity, but rather reinforces it, as its minimalist aesthetic follows Tesla's philosophy of objective functionality, prioritizing aerodynamics, structural lightness, and production efficiency, resulting in a modern, elegant, and disciplined car, capable of pleasing consumers without visual excesses. The decision to remove elements such as panoramic roofs and complex lighting systems reduces costs and weight, increasing energy efficiency and autonomy, demonstrating that simplicity can be a path to innovation when applied with intention and strategic precision. The evolution of the Model 2 will be continuous as Tesla uses millions of connected vehicles to collect data that improves software, drivability, energy consumption, and safety, creating a constant refinement process that makes the car better over time, something that combustion engine vehicles have never been able to offer. The environmental impact of the Model 2 extends beyond the absence of emissions, as its production cycle based on recyclable aluminum drastically reduces the ecological footprint of manufacturing, transforming each unit into a concrete step towards a more sustainable planet and aligned with global carbon reduction goals.